Oh, snap. Crackle pop. Okay. I've been looking at earthquakes. It's a little weird, I know. Pardon me. It's odd. All with like things around it because now I'm looking at like tragic events and like gleefully learning from them almost in some ways. Like what I'm about to say is like, whoa, dude. This kind of makes some sense that there's this aspect of it going on. So I was just watching my Quakes video. I was almost done. Basically, I just recorded like 50 minutes of me with my microphone muted about 2 hours ago, and I got a little sad. Maybe an hour ago, hour and a half. Then I realized, oh, I've been muted for like 30 minutes. Crap. But I was basically really slowly going through the New Madrid other things. I was going through my notes. I've been taking notes. Got several pages of notes now. And I was talking about the Loma Prieta earthquake, which occurred here. And caused energy to propagate this way. And I was saying down the boundary, and just kind of thinking that made sense, and that this system, like, decayed and propagated energy. I don't know. Maybe I should look into it right now, real quick. Loma Prieta earthquake subsidence. If, if the region above subsided or I think it elevated. Either way, it kind of doesn't matter. Like it's almost like the difference being reaction types. I don't know if this is endothermic. Maybe activation energy. Here we go. Like this. Initial equilibrium. Some like sudden change reaction, some catalyst, essentially, because what I think is happening is there's layers, many, just these really big layers that like the plates are, the continents are, and then those layers lay atop a second layer that has surface roughness. So it's basically this. This is its surface roughness, and so the crust is atop it where there is continental crust. Where there is not continental crust, it's just more laminar flow, maybe, where over here, because it was flowing on beneath the actual continents. It was caused to flow in ways where it basically ended up producing support structures. Just had a thought that these are like rays and these are like particles. There's a little heart. Oh, there's a little heart. Blowing a little kiss. And a bigger heart. And a bigger. Oh, the Look how big the hearts go. They go all the way up here. Marco. Okay, so what was I saying? So I was thinking though that the essentially this earthquake when it it's a layer though, but then within the between the layers are like more dense particles essentially that are literally particles. Sometimes they're like spherical, sometimes not, but at times they are, or at least like even if their outer shell is not, they're still like they behave like particles, like this, or like a oh yeah, I had another like that like even though the outer boundary is not a sphere, it has a sphere within it. So like even though the pillar, like these things are not like spheres, they probably have denser structures within it that are spheres, or maybe even the same way as it's like this. Sometimes they have like void centers that can be compacted, and so it's easy to like compact that spot because it has this big void in it with enough pressure, and so like it can drop the energy. Or if it's like a sphere that's actually like a solid particle there and it has pressure on it, then it will like expand like and create a new, basically create the void type situation, but by uplifting the system and exciting it in a way where over here it's more going back to equilibrium of like caving in, so that all the pressure of things hanging above just kind of fall to an equilibrium. And so like when the particle, I'm sorry, when the particle gets squeezed, it maybe it gets squeezed like more like this to a degree because of just the way the general currents are, and then because there's a fault line there, a boundary, it's kind of a place where like the lowest density particles are. Maybe it's more like clay or easy, just something less, more easily able to flow along. And so like the energy of the earthquake then goes to that like nearest fault line, propagating energy along the way, but really like going along a focused current where it then like reaches a inlet here. So there was a current coming in, creating this bay, the bays, and then it continued to flow in. But because of that propagation of energy preferentially went those paths and caused like epicenters of this earthquake in San Francisco and Oakland. And then I was saying, I was kind of like, I noticed in the video something I didn't notice when I was watching it. I didn't notice when I was speaking. I was talking about how it kind of goes over here and maybe it goes across here and maybe it influences here. It occurred to me that yeah, like it's going over here, but it's like even going right over to like to where there's this kind of X region, so it's kind of crossing over into here. And even more than that, it's really like going all the way to Yellowstone. I didn't even realize that part of it. So there's that going on where it's kind of following this path. I guess it's showing me accidents because of something. Um, yeah, so like that's probably going on. And for sure that propagate. My God, I wonder if like that happening caused the energy to propagate this way. Like it's still going, kind of moving like dominoes this way, and maybe somewhere it'll kind of like break a dam and cause a more like an earthquake along this path. And maybe it contributes to like that kind of thing happens. And maybe they follow preferential paths like this goes this way, this way, this way, this way, this way, like it doesn't go really this way maybe. Okay, so back over here though. Here's the New Madrid region right here. And then the fault line goes up this way, seemingly. And it occurred to me that yeah, there is this fault line, and what they're seeing though. So here I've pinpointed Madrid was here, New Madrid, here. There's this little like pillar, and then like a small point in the center of an eye. Really, like an eye shape, interesting. And this like little point has New Madrid there. And then the cutting this way is this, which appears kind of like to go here. So it looks kind of related to this. It occurred to me though, like, wait a minute. Because when I saw this picture, like 10 seconds ago, this picture, I was like, oh my God. I wonder if this is like I wonder if this is one of that current I was looking at up here. Like this thing is so detectable up here. Look at how it's just carving a path through here. But if we follow it, New Madrid, and then cuts out into this region. Where it really continues across this region, across it, to maybe around here. Which is at this hinge point where basically North America was this way, and then it bent this way while maintaining this position up here. From up here, it just like physically moved this way and bent inward at that point, which is really close to where this current is. This current, maybe, it may be the current that essentially, so I maybe to put some, I need to give some details. I don't want to continuously repeat details. But the mantle was punctured under the crust by a vortex storm so potent that it brought space itself down through the crust and into the underneath the crust. And it then caused this basically an upwelling from this region of the mantle beneath the crust to flow in all directions, which then ended up pushing mounds and places where the currents preferentially flowed. So where currents were pushing mounds and not flowing versus where currents were just continuously flowing. And so they flowed in all directions, but then the earth is spinning, and so it preferentially created like a larger fanning out in this direction, especially in this, like initially going, this is mind you along the equator here and along the equator here, because the earth had yet to expand. It was a single landmass. And so the current from here goes up this way through basically through Europe and fans out though because it's going with the rotation of the earth, whereas the current going in the other direction gets more into a focused it gets more channeled into a focused current essentially, and so it only can go in that direction. Otherwise, it bends off pretty much. And then some comes down this way, which is along the boundary of India and Africa. Pardon me for all my me. And then it comes down this way, generally speaking, along the boundary, eastern boundary of Africa, and then through it as well. Probably like this way, like here specifically, where there's a current coming across here that's kind of creating a boundary. Essentially the boundary of one current coming through from South America into Africa here, going eastward, and then the southward propagating current from the mantle puncture hole that then wraps around this way, and then through southern South America, not where the current coming from over here comes down here, through here, and then enters South America here after passing this current, and so it fans out because it doesn't have the same resistance. And then goes through to here, and then it meets the current here, so it kind of wraps around basically back up this way and just goes back that way, but then creates a boundary and widens this region while just putting more of a current over here in this boundary as well, really shaping the region. I just spitballed that, sorry if that's not appropriate. I'm like, I'm feeling it. But so the current from here though goes over here under South America, but then it goes into, which was physically connected along here to here. This was just connected like around here, and then this was just folded up there. And so the current coming across was going through Antarctica, right through that way, and then right through here, which then went into here. In through here, and through, out through, over, initially through here. And this current then collides with the current coming from underneath Central America, the large wide current, as well as collides with the narrow focus current coming around along. Basically it collides with this current and this current. So there's these currents colliding with this current in this region around here. And so like this current goes somewhere. Like I was thinking maybe it goes this way, but it carves in here. It carves into this and like cycles this out. and basically decays the nucleus from like a particle that was here, this large like radius with a nucleus around here, and it causes it to spiral out and decay to a new stable platform, which with supporting platforms, it's almost like a maybe a hydrogen, hydrogen, oxygen. That would be cool. That would be so cool. With a hydrogen bond to, yeah, I don't know. Pardon me. There's really more than just those three. Those are just like the largest scale ones. So maybe on like that plane of existence, they interact with one another in that kind of way. I know it sounds ridiculous, but I've been talking about it a lot, and there's a lot of evidence for it. That this is what like this is the best representation of how atoms really function. Is in the geology of the Earth really shows it like in its infinite depth, practically, relatively speaking, at least to a degree. Pardon me. Okay, so this current though probably does actually like participate in widening this. Like maybe it comes up through here this way and then it hits this boundary and just goes along the boundary here and out through like this way and just essentially at some point just out through this way and creates this opening here by crossing with another current, because essentially it's out of sync. There's one current going this way, there's another current going this way. They're not going the same direction. They're in the same location. So what do they do when they collide except for create like openings around the point of collision, basically, that then the above surface is caused to like fan outward and take the shape of it, basically, and within becomes just like a gaping hole of just like magma lava that then solidifies as just the ocean floor in that region, while then forming islands that take the shapes while this current is still going through. There's a current here, there's a large current here, and there's a current about this wide-ish going here, probably about that wide, based on this. Pretty much going that way, I guess, through. It looks like it goes through here, under Papua New Guinea, like right around its arm. I don't like around here. The day this map gets filled in, oh my god. I'll be like, can only guess at what might be missing. Okay, so maybe though maybe what's going on here is a current that's like physically just cutting across here and just goes up into this current through here across. I was gonna say to Iceland, but that's not Iceland. Iceland's there. Up here, across here, maybe even down through the Red Sea and holding that boundary. And then it just like finds a way out into the open here, so it goes that way. Like bubbles to the surface pretty much because the surface is just an opening in the earth that's getting filled with like the blood of the earth practically. So the New Madrid though, I was thinking, let's see, what can I say? There were 3 magnitude 8 earthquakes. I think it was 8. I just wrote that down, but with like an approximation. I know they were in that region. Let's just say New Madrid quakes 7.2 to 8.2. Okay. Let's see. Our series beginning with an initial quake of moment magnitude. Oh, okay. 7.2 to 8.2, followed by a moment magnitude 7.4 aftershock on the same day. 2 additional quakes of similar magnitude followed in January and February. So they have 4. Damn. Like, to me, it's almost like radioactive decay, where it's like it doesn't just happen once, it happens, and then it happens at a certain like amount of time within the same period. Like, let's see, decay sequence for of, yeah, let's say that. Let's just say uranium. Maybe I can find something that kind of has half-lives. Highly stable, but then like 24 days, 1 minute, 1 minute. I don't know if that's the same. That looks like 2 different options. I don't even know it's the same. I don't know. Daughter. Oh. $6.7. I don't even know what A is. Is that years? It's gotta be years. Okay. Yeah, this kind of thing. Maybe. Where there was one at the morning of this day, and then that caused a new stable system to emerge, but it wasn't that stable, so within a short half-life, it decayed. And then it was more stable, the system that emerged, but it still wasn't that stable, so it decayed and decayed again. And then it seems to have reached a more stable equilibrium. Although there are smaller quakes still going on. So like this. It's crazy we can detect it there, but haven't detected it more in like a more clear place like here. I wonder, where is this right here? Here's this. So it's just past the Appalachians. Wait. This comes in. Yeah. Yeah, yeah. Okay, okay. This region, then it's got this. Let's just see. That's 73.50. Maybe around there. $73.50.85. Seventy 50.94, 73.5. I know, pardon me, guys. 53. I can find it, I swear. 53 point. 73. Oh, 50.93. 73.5. 50.93. 70. So those are like over here. Whoa, that looks crazy. Is that here? Here? Who knows? Looks like it's kinda... probably that one. 68.3, 50.8 or something. Not centered on it. Let's see. I'll write it down this time. $68.7. And then what? 51.4. Oh, it's centered on like this thing. Interesting. There's a circle there. I don't know if that's the other place. 50.5, 67.5. Nope. It's like here. So that's like this support structure in the region, I guess, is kind of like And there's one here. One there. I don't know if... I don't know. It's hard to say if this, like... if it matches to that degree. I don't... Sometimes it's like, I mean, let's move on before I'm like, I don't know what to make of this, and it's just too, like, clear that it's, like, a little confusing. But I don't want to make it like I'm, like, avoiding it, though. Like, it just seems like maybe, in terms, if that doesn't make sense, like, this seems like it should have something more clear in this. Like, we can kind of see the Hudson Bay, so I guess the Hudson Bay also doesn't quite have the exact shape. Oh my god, I just had this thought. What if it has like a mirror shape over here to this? And then this like connects energetically. So it's like a water one atop the lava one that then connects down to the lakes, which then fed down to like this region, generally speaking. Like this whole region filled with water, especially. That especially drained through here. Like that way, like boom. Just a strong current coming out that way. But also some coming through here, crossing there. It's almost like an eyeball, mouth, tongue. Oh, Lord. Let's see, do we see similar features in this? Like, are there eyeballs and eyeballs and then tongue? This would have to be mouth. For this to be tongue, it would have to be mouth back to here. I don't see anything particular. This looks almost like a dragon's head here. Eyeball, like eyebrow region, snout, flame. Across here. Like it is probably caused to flow this way over here, where it then mixes with the water in this region and solidifies enough to create like just walls of material, and then goes around this way, but also goes around this way. where it then just hits this current up here, so it like goes up that way. This current up here has a branch off current going this way, which then goes over here. This one goes to Iceland, and then cuts across to into here, into this region, maybe even just right through it, like carving a path through me and joining this stream in its own way from there. But then it basically produces a wall where this current then goes up to that boundary wall and then moves inward. Although this seems like it's going this way, I'm not sure what would go this way. Just because it goes there, this doesn't really make sense to just be like, whoop. Unless it's really meeting resistance, then maybe it's like a balance point where it just kind of goes there and then slows and goes that way, kind of. Maybe I guess that's possible, especially if there's like multiple parallel ones here, but not like just many of them. Where like the general current coming through here generally produces a boundary there, secondary boundary, and then this current produces the primary boundary with this current, and then its own secondary boundary, and they both kind of flow in to join one another past the boundary down here. through here, where they then run into this region. That's probably why there's this Nova Center here. This whole region that looks like a face that has a yin and yang, with a yin and yang like within another one there. Lots of cool stuff. The whole region here pretty much being yin and yang. But that's right here where that face is. And then the secondary region there. Yellowstone is down here at the focal point of this magnetic field region. At least essentially where the currents are flowing here and then around and into here by just pressures pushing them back into this region so that they flow like from the backside and fill, because essentially it built a wall, but it was more so over here, so it kind of became like a cup that had space to fill, that essentially encouraged the flows to flow that way. The third New Madrid earthquake caused a lake to form, so it balanced out the system to a degree, almost decayed it in a way where it took a imbalance. It's almost like what's on the two sides is so out of balance that it decays one down to meet like a stable. It makes me think of hydrogen versus hydrogen being like way down at the base, so there's not really a lower point to fall to without like totally falling to a new like octave. But generally within that span, it's at the base. That's like where it's stable at, where every like up to uranium is almost like something like more like this. So like the surface layer behaves like uranium above this like boundary, not to say uranium specifically, but in that way where it can decay more readily because it doesn't have the support structure to keep it. So maybe that's what's going on with the uranium and radioactive atoms is they are just so expanded outwards. Like all of their innards are physically out to a point where like to take anything more out is to just like create this bubble, this little like even though it adds new material by adding mass, but like it's still expanding it. So maybe it's just adding mass by adding mass of space to a degree. That is itself, I guess, transformed because it's ether, it's particles. It must be like vortexed into becoming larger systems. But then it just is, it's still out of a base substance, maybe of ether that tends to being more like the more higher up towards uranium and so on, the more it like tends to have too much like space within it, even though it's very, I don't know if that makes sense. It would be cool if something like that made sense. It probably does on some, like when it's reasoned out completely. That probably doesn't make sense, but like the elements of it that could be like that there's something of that nature going on. That okay. Let's move on before I just try to defend the things I say too much because I feel like that wasn't that bad. Micro earthquakes continue to today. Almost rifted like the East African rift. So that it like it really makes me think it's like a sheet, like a continuous crust, but that crust just like cracked pretty much, but it because of the lack of a support structure, like it bowed in and by this carving water pretty much, not just flowing, just carving down into, not just like resting on it, but physically flowing into every pore that it can and down like water can do, and just carving, but not to a point to actually do it, but enough to have like almost rifted the region. Okay, a similar failed rift found near Bhuj, the Gujarat. I didn't look into that exactly. They just said that, and that's all that I know about it. Because then they moved on, but and I didn't look into it. Okay, largest earthquake ever recorded was in Chile on May 22nd, 1960, in at 9.5 magnitude. Let's just quickly go through some details now. But I think I said the thing that was popping in my head, which occurred in Valdivia, somewhere around here, where what I heard of being impacted was down here, I believe. Moyen Vaidivia. Claimed to be caused by Nazca plate subducting under South America. But maybe not. Maybe actually what's going on is again like a similar thing where there's just this like unstable system. So let's see. Ground dropped 2 meters in a region. This one, 200,000 kilometers squared area subsided. Tsunami, this I found really interesting, unfortunate but interesting, is the tsunami from this earthquake hit Japan, Hilo, Hawaii, Philippines and the west coast of the United States. And let's just look at this. Like this. So I was just watching this. This is apparently what this was a crazy, crazy earthquake. Apparently, like 6 meter waves in Japan or something. But if notice the waves are not like they're not traveling as like an evenly distributed wave. Like they're actually starting to accumulate, and even where they're accumulating is kind of falling behind and in, but still like focused at a point. So this earthquake, it really focuses energy right over to this region, especially to like Japan and maybe there around Japan, in a way where the earth just like, and then it creates a flame. It creates a flame. I've been talking about these flames. In a way, though, where this earthquake energetically propagated into and exchanged energy into Japan, to a place that like probably energetically needed it because of its instability, where over here was maybe like just couldn't, it just was more less stable. So it just like to stabilize overall, it collapsed down, earthquake, sending energy over here, although maybe that's not the outcome in Japan. I don't know. It doesn't seem like that would be good, but in terms of like the energy going into already concerning region besides the tsunami itself, but in terms of like the energy and its stable, like the stability of the island. But I was thinking maybe it does like these earthquakes on the coastlines that are causing waves to propagate, or just the general gist of it, like that propagated there, whereas the one at here went up here and focused over here. So they both focused energy, even through the ocean, it still got focused. So maybe there's like a exchange of energy of that kind of nature going on. Okay, let's move on. Evidence of a dozen earthquakes in Chile of similar magnitude dating back. Well, I don't think I said. Let's see, what did I write? The Loma Prieta caused a coastal uplift of 4.3 feet. Coastal uplift. Oh, so energy like did propagate out. So I guess it caused and some of it to go like outward towards like the open where it's more free to move, maybe even like bubble out from under the crust if that could ever happen. I mean, I think it happened here, like that kind of thing going on is like a current that just flowed from under the crust between some kind of opening and just was like basalt pretty much flowing into the newly forming ocean bed, but then it's solidified and it's really solid, so I'm not sure if the currents can get out that well. But maybe it could happen and just like burst out the side and create like a platform that stabilizes the region to a degree. Like that's what it's doing. It's tending towards equilibrium. To a degree. Although, what exactly tending towards equilibrium entails, like which equilibrium? There's all sorts of equilibriums. This is just a scale. Like, there's other equilibriums that can tend towards, like, the equilibrium of just space itself, etc. So it's not like completely in balance. Like, and then it's in balance. Like, there's all sorts of things going on. That's why the universe is like as it is, not just like at equilibrium. Fault. I found this interesting. Oh yeah, and then it slipped 6 feet, and then uh, sideways, and then it with a total slip up and side at a diagonal of 7.5 feet. So there's that. A fault is considered active if it has moved in the last 10,000 years. So it's pretty much considered a fault is considered active. Interestingly, if it's basically still active since the Earth stopped expanding. Crazy. Because the Earth hasn't stopped expanding, just like the process is mostly stopped. Or the process is not done, but it's like mostly stopped, so all we see is these active faults instead of like the whole of the process anymore. Earthquakes travel slower with more shaking through mud and sand and softer, less unified materials. I added. I was just watching this one maybe. Yeah, this one. This is notes from this one. Pardon me, ma'am, from just details in this. But I added likely mud and sand being present in the first place is a function of the currents. Like it's not just like and then the earthquake propagates energy to that really causes like problems where there's mud and sand. It's like the energy, the currents were already propagating that way in the overall currents at some point that like caused crystal differentiation and like all sorts of differentiation and like pulverizing and making like finer grain materials where there's just like big particles flowing through and smashing little ones practically and creating a channel for the larger systems to flow through that are just experiencing a force behind them that essentially carve the channel by the pressure. So once the currents stop flowing, it stabilizes, but there's still the path there. And so, like, there's still the outcome of the paths, inclusive of, like, places where there's more mud and sand. And those would be places where, like, energy that's, like, bouncing off of the walls, of the denser walls, kind of just, like, mostly funnels through the more subtle material and out of this like escape route for the energy to just like so maybe there's something of that nature going on with the mud and sand and beyond just like that it is more like dangerous in those regions and it's because there's more shaking in mud and sand. Like there's also more shaking in mud and sand because the mud and sand was put there by the more shaking before when the currents were just flowing continuously, where it's not shaking anymore. It's not like vibrating. It's just a flow, which occurred everywhere on Earth. Okay. 7 major Santa Cruz earthquakes since 1850. They talked about. Uh, let's see. I don't want to go through all of this. I found this one interesting. A double earthquake at Monterey Bay. 4:35 and 5:35 a.m. 6.1 and 6.3 magnitudes. And then the Loma Prieta, so another like radioactive decay type of example where it occurs more than once. Supernovas also can occur more than once. It's a thing that can happen, and then even just like if we look around, if I can zoom out here, like this has multiple rings. So it happened more than once, maybe, to a degree, like multiple rings. Where there's not always multiple rings. Or like this one has maybe 2 rings more so, rather than 3. Or like there, although that looks like it has another ring there. Kind of curious by the structure that looks like a heart now. Like, what's up with that? Okay. Another thing about Loma Prieta is the epicenter, which is the point above where the earthquake happened. Like it was was 3 miles from the fault line. Basically, if the fault line is a main location where currents are flowing, like 2 adjacent currents, one flowing in northward, one going southward in this instance, adjacent to one another, and so they create like a place for currents to flow, like a highway. And so the currents flow along the highway, but that's not where the particles like amass. The particles amass along the boundary of the highway. And so like for one of the particles to like collapse to a more stable equilibrium, it would make sense it wouldn't be along the fault line, but instead it would be like near it. Mind you, this is something that doesn't really make sense with plate tectonics. Is Loma Prieta earthquake images, geology, slip, maybe. Essentially, what geology says is there's these 2 plates. They're moving relative to one another. And somehow, when they like jerk, because they're like stuck, they're pretty much, they're like this. They're stuck on like this. And so they get kind of stuck, but then they get like past it, so they jerk, kind of thing. Somehow, that results in an epicenter of an earthquake. It doesn't actually make sense because it's not like the sliding is only at that point. Like it's literally the whole length. So like I know it has some aspects of making sense, but when it's like repetitively not long, like long, at least like some length, like elongated epicenters. Where's the elongated epicenters? We see particulate epicenters, which is not really at all in favor of plate tectonics. It really isn't. It makes no actual sense. I guess if it's suggested to be like a wave composed of particles, like a wave particle duality, where maybe this is a particle, and then a particle, and then a particle, and then a particle, and then it's an elongated wave, and now we have a wave, and there it is. And it took all of them to see it, because that's how things on different scales and magnitudes work. But like, in the traditional sense of plate tectonics, it's really not happening. I mean, that's the only way, is what I just said, though, is something where it's like pixelated. Because it doesn't actually make sense with things sliding and then just a tiny point really having like this slip occur when they finally break past one another. Like, they should have like a jerking motion, and then beyond that, they probably shouldn't really quake. Like, why are they sliding past one another and then like shaking? Like, it makes more sense for there to be a shake if there's like a radiating system, like a supernova, but of a small particle within the layer of the Earth, and novas under the pressure of the crust above it pushing down on it, so it physically radioactively decays to a subtler system that doesn't have to have the pressure so focused on it. And then shockwave. But like a supernova lasts for a period of time where it's just like energy radiating. So if it's like radiating into things, it will cause those things to wiggle and to quake. Unlike something sliding past something that really, like, maybe to a degree, but it really doesn't make sense. Not in the way that novas of particles can actually explain the nuances. Okay, let's see. 1964 earthquake in Alaska. How long is this? Okay. Called subsidence zone 2 meters within Alaska. Like, it was here. So around, earthquake was around here somewhere. Here. This region was subsided by 2 meters. But then this region uplifted by up to 9 meters. And then I wrote, maybe the nova is like a way of generally the overall pressure. Like, there's generally pressure here. There's all of Alaska is generally applying a pressure into the support structure of Alaska here, which is really not that noticeable. so its weight is on it. And here, there's an earthquake in this region. So essentially, I'm thinking, like, maybe, like, it's moving this material generally outward towards, like, this boundary. And just because there's kind of like a wall here, like this wall, it, like, prevents this stuff that's kind of rolling downhill, if you will, going this way from, like, going further, so it kind of accumulated here, but then it subsided here. That kind of makes sense. Uplifted and accumulated and subsided. Okay. Earthquake clusters in the last 20,000 or the last 10,000 years. There were 20 earthquakes in the Pacific Northwest. Sorry. There were 20 earthquakes in the Pacific Northwest in the last 10,000 years that were greater than 9 magnitude earthquakes. And they occurred in clusters. Which probably happens with radioactive decay. I noticed there were, like, certain ones that decayed at the same rate. .159. Or wait, that's the same one. Let's find some that are not the same one. Let's see. Those are the same one. Oh, that's why they're the same rate. This is probably too high in the sequence. Like, I don't think it's representative of what I'm actually looking at. It would be probably more accurate to be something with just more stable and less, more like isotopes, maybe. Let's look at some isotopes. How about isotopes of, I don't know, how about most abundant? Yeah, let's go with zinc. Why not? Isotopes of zinc. Just for lols. Yeah, so, like, that kind of thing where maybe yeah, pretty much goes from like 45 hours, 2 minutes, almost is like an aftershock, earthquake, aftershock, stable. Or starting from here, just a single earthquake, and then stable. Single earthquake, stable. Let's look at some other elements. Iron. I guess there were more. 54. Whoa. Let's go up here. Observationally stable. Beta decay is emitting a beta particle or emission of an electron. What's a beta particle again? Oh Lord. Current. Contained current. Yeah. Okay. Let's keep going though. Oh, that was it. Okay. So, did we find something that connected to Iceland? Let me look at that real quick. That one. Oh, yeah, that's right. It seems to be actually this current. So, probably. Is current coming in this way? Up this way, up this way. Just thinking, what's up with this? Like, does it go past there? This comes up this way, like wraps to a degree. Like wraps in a little bit and then back out. And then this comes this way, so it still creates a boundary because of that, but they're still both moving this way, maybe. I'm not sure. This really... Because initially it's coming out fully that way, but then it does have all these features. So maybe over here, as it's like the current is going across the boundary, it's causing some back pressure that then swirls basically and creates mounding in the region of that boundary here. And over here, maybe to a degree where there's like a pinching of currents here. Like this general boundary. Which is pretty good boundary because currents are flowing along the boundary most readily. So it's flowing that way, and then right to what ended up being where Iceland would be. And then over here... Really, Iceland seems in the minimum related to this current, just basically producing a mound and then causing itself to wrap around, which happened in India. Essentially, there's a current of of basalt on the surface here that flows out this way, following this arrow path, and goes this way and builds a mound here that then causes resistance this way. So then it starts flowing this way, where it meets resistance again. And so because it meets resistance here, it then is caused to bend again, but then there's resistance here from the current flowing in this way. And so it just fills this region, and causes this current to swirl and produce this mound and this thing. And so we have this current coming across, hitting this wall of resistance, where it then is caused to turn back and collide with itself, as well as this current. Collide and turn back. Not all of it, some of it continues through, but some of it collides and turns back. Flows this way. And just contributes to, maybe to that there's 3 pinch points, not just 2. There's one flowing in that has the boundary creating a pinch point here. And then the larger current as a whole deflects back and pinches back again on the same location, as well as this current flowing this way flows into that location to a degree. And across from here, is that what's going on there? Oh shit. It may be that this current here wraps up this way and manages in part to break across here, and come through here though, so no, I don't think that's in line. Although maybe it doesn't really, it's not visible there so much. This one seems more like this current comes in across this way and pushes out and kind of just flows down here because of the pressures. So for sure there's a current going this way. So it must be going this way, and for sure there's a current going this way. So it's just, it lends itself to being a current going this way. And there's no boundary here. There would be a boundary here if it was a current going this way, adjacent to this. There's just no boundary. So it's really suggestive that this is going this way, through here, which maybe continues through here, crosses through here, maybe into here actually then. That stretch influencing it. It looks like it takes like this mound and kind of scatters it this way. Like it doesn't have material to be, it doesn't really make sense for it to take a void and spread it out along this path. Like it needs something to take it from, and it's here. So it must have gone this way into this current from up here, from Iceland down through here, which then went to here, and apparently happened while it was still attached. Maybe to here, like right here. I don't know if that makes sense. Here. I don't know if it's that soon. It's gotta be farther than that. Here. The boundary is here. It's not that far, I guess. 1, 2. It's really not that far. Let's go from this corner one, like maybe to here. So it may actually be coming in here. Down like this way, and maybe below it. Because it looks like it's going generally that way. This is connected to South America, though. Could this be that way? Maybe. Just kind of creating this region, shaping this region, and then more so merging with the current over here. I don't know. Okay, it's late enough. I'll see y'all's later. I hope this comes to fruition soon. I'm freaking exhausted. Watch this one. Okay, see y'all soon.